Woohoo! Welcome back. Tonight we're going to be dealing with inverses. Woohoo! Again! Yay! And we're going to start off this video by using a graph to find the inverse of a function. So, hopefully, as you look at this function, you see, f of x equals radical x plus 2, and you think, this kind of looks like part of a parabola. And you'd be right. Yay, you guys are awesome and amazing. And you'll also say, it looks like it's been shifted. X plus 2, that means I've added 2 inside the function, which means the function itself shifted to the left. In which case, I would say gold star for you. You guys are awesome. There is actually a starting point of -2, 0 here. And then I have asked Desmos to very kindly write in these coordinates, although I realize they're kind of small, so let me write them slightly larger with black ink, so hopefully they will be easier to read. The points are -2, 0, 2, 2, 7, 3, and 14, 4. And if you try them out, for example, if you try 7, x equals 7, you put that in, 7 plus 2 is 9. Radical 9 is 3. There you go. So how do I find the inverse of this function? Well, what I'm going to do is I'm going to take each of these points, I've got 4 of them, and I'm going to write them in reversed order. So what do I mean by that? -2, 0 becomes 0, -2. 2, 2, well, 2, 2 is nice and easy. 2, 2 becomes 2, 2. It's either easy or boring. 7, 3 becomes 3, 7. And 14, 4 becomes 4, 14. So we just reverse the order. Remember, inverses take the input, make it the output, and vice versa. So, having done that, let's take a look here. I need, let's see, I've got 0, 2, 3, and 4 as my inputs, as my x values. Squinch this up a little bit. And -2, 2, 7, and 14 is my outputs. So I'm going to put my x-axis right here. And then I'm going to put my y-axis right here. Remember, boys and girls, do not try this at home. Well, no, actually, strike that. Try this at home. But maybe use a ruler because Wiggly. I definitely took us to Wiggly Town there. Okay, so let's see. 0, -2 is going to look like this. 2, 2 is going to be right here. 3, 7, so if that's 2, 3, 4, there's 5, 6, there's 7, 3, 7 is going to be right there. And then let's see if I can get the next one in. The next one is going to be 4, 14, 8, 9, 10, 11, 12, 13, 4. There's 14. Yay, it's big enough. So here is 1, 2, 3, 4. So 4, 14 is right there. And I see, it looks to me like the curve curves up like this. What do you guys think? There we go. So if this is the function f of x, then this is the function f inverse of x. And all I did was I just took a selection of points and I reversed the x and y, and I connected the dots. Now, could I find more points? Absolutely. Absolutely. I could go looking at what happens when x is 4, for example. It's a little bit tricksy, but it's whatever the square, oops, sorry, you can't see that. At 4, this is going to be whatever the square root of 6 is. So it's not a nice even number. It's not like these all are integers. This would be a real number, an irrational number, but you can go ahead and estimate it and then do some estimating on the graph as well. You don't have to stick to integers. They're just easier, and so I thought I would stick to them. So again, this is f. This is f inverse. You guys are awesome. Woohoo! Okay, next page. Last page. Exciting page. What are we going to do here? Dun, dun, dun! We've got a property. The inverse function property. And what I've done to try to make it a little easier to read is I have written f as black and f inverse as red, if you can see that. Hopefully it shows up and you're able to perceive it, but I will also read it. Let f be a one-to-one function. So in other words, 1x goes to 1y, 1y goes to 1x, with domain A and range B. Okay, so for f has A goes into B. The inverse function f inverse satisfies the following cancellation properties. F inverse of f of x has to equal x. So if you put x into f and then you put that into f inverse, you have to get back to x. Or if you take x and put it into f inverse and then put that into f, you have to also get back to x. So you have to be able to use f inverse either on the outside or the inside, and it has to cancel out or undo f. Conversely, any function f inverse satisfying these equations is the inverse. So in other words, if it's the inverse, this is true. If this is true, it is the inverse. Now, let me finish this thought. Keep in mind, f inverse is going to reverse your domain and range. So just keep that in mind. Okay, this is a lot. It's beautiful. It's wonderful, but it is a lot. So what the heck does it say? Well, basically what it's saying is if you get two different functions, 3x and x divided by 3. Now, hopefully, if I say that to you, you go, oh, well, if one multiplies the number by 3 and the other one divides the number by 3, yeah, they undo each other. They're undoing each other. But how do I prove that? So what you do is first, you pick one direction. I'm going to do f of g of x and see what it equals. So f of, now g of x says x divided by 3. F says whatever you get in, you multiply by 3. So it'll be 3 times x divided by 3. Well, if I have 3 times x divided by 3, that's 3 over 1 times x over 3. The 3's cancel. Oh my goodness. Oh, what luck. That equals x. So if I compose these two, x comes out. They undo each other. Now, is that enough? Sometimes it is. It depends on the situation. But the rule is you have to try it in both directions. So I reverse this. There's a lot of reversals going on. I'm sure this is, inverses are the situation comedy of the math world, I'm sure. So this is g of, and f of x is 3x, so you're supposed to do 3x. Okay, g of 3x, g says take whatever you get in and divide by 3. So 3x over 3. I don't know why that 3 looks like that. Obviously, I'm very excited. Who wouldn't be very excited by inverse functions? Let's try that again. Oh, so much better. Okay, so 3x over 3, and I'm writing it a second time just to try to redeem myself. But the 3 cancels. Oh my goodness. And we get x. Oh my goodness. So we compose them, one f of g, one g of f. If they are both x, then f and g are inverses. Woohoo! You guys, we did it! Ah, this is awesome. This is the end of chapter 2. It isn't the end of your homework, though, so give your homework a try. I have not gone over every possible problem. There's going to be lots of stuff that could snag you, stuff that may be still confusing. So please do not hesitate to ask me questions. If you get stuck, ask the tutors. We would love to explain this. And, give yourself a break. Make sure you take some time for yourself. Make sure you stay hydrated, and, you got some good snacks and some a cozy place to be while you do your homework. And, pat yourself on the back, because you're amazing and brilliant and awesome and incredible. And I just think the world of you. So take care, give yourself a little break, and then math on. Woohoo.